So let's jump to worksheet 8.3, WSPM, and they want us to identify the asymptotes. The asymptotes is the lines that they infinitely approach but never touch, the domain and the range of each function, okay? So let's take a look at number 1 right here, and you could visually see that this one, as it goes to the right, what does it infinitely approach? It infinitely approaches the x-axis. So the x-axis is your horizontal asymptote. What's your vertical asymptote? Is it x equals 0? No, it's not. It's over here. Both of these graphs infinitely approach this line right here, which is a vertical asymptote, x equals 1. Does that make sense? Yay or nay? No? Okay. Let's take a look at this graph right here. As it goes to the left, does it keep going up forever? No. It infinitely approaches what? It infinitely approaches the x-axis. Yay? So that x-axis is an asymptote. If I were to draw this line right here, the x-axis line, those graphs will never actually touch that red line. Now, what is the equation of that red line? Well, you could call it the x-axis, but the actual equation for a horizontal line would be y equals 0. Does that make sense? Okay. Now, the other one, the other asymptote is a vertical asymptote. Okay. Now, the vertical asymptote is the one running up and down. That would be this guy right here. Okay. What's that line called? X equals, is it x equals 0? No, because the y-axis is x equals 0. This one's moved over 1. What is that one? That's x equals what? Anybody? 1. Thank you. So we have our both asymptotes, y equals 0 and x equals 1. Now, that could be a little confusing, especially when you're looking at them. So let's do something else. Let's go back to vertex form equation. You guys remember vertex form for parabolas? Y equals a parentheses x minus h squared plus k. You guys remember that? Yes. Okay. Now the h value is always with x, and you always think opposite for the h value. Yay? Okay. The k value is always by itself at the end, and you take it for what it is. Yes? Okay. So technically, we're going to use that same idea that the h value is always with x. So let's go back and let's look at the actual function of this hyperbola. These are called hyperbolas, by the way. These curves that infinitely approach lines but never actually touch. Here's the function. Now let me ask you this. What's the h value? Remember, h is always in parentheses with x, and you have to think opposite. So what is the h value of what you see right there? The h value is, anybody? H value is what? Hint, what's the opposite of minus 1? 1, right? Or positive 1, that's right. So the h value is 1, and ladies and gentlemen, that is your vertical asymptote. Just write it as an equation, x equals 1. That'll be your vertical asymptote. Now, what's your k value of this whole function? Do you have plus some number or minus some number at the very end? Yes or no? You have your fraction. Do you have plus k out here or minus k out here? No. So what's your k value? Your k value is 0. That's right. K equals 0. And that is your horizontal asymptote. So you would say y equals 0. And that'll give you your horizontal asymptote. So you don't have to do it visually, where you say, oh, my horizontal asymptote is y equals 0. My vertical asymptote is x equals 1. You could simply look at h and k and find your horizontal and vertical asymptotes. Isn't that a lot easier? Yeah? Okay, another thing that they ask us to do is state domain and range. So if I look at this hyperbola, which is kind of like a curve right here, infinitely approaching the lines, and a curve over here in the opposite direction that infinitely approaches those lines, does this graph go to the left forever and the right forever? Yes. So your domain would be x, what? All real numbers, right? But x cannot be 1. Now, you could clearly see that at your 1 value, it doesn't exist. There is no coordinate because it infinitely approaches, never actually touches. Or you could even look at it algebraically and say, if my x value was 1, 1 take away 1 will give me 0, and that'll make it undefined. Isn't that right? So your domain is x equals all real numbers, but x cannot be 1. How about your range? What's your range on this guy? Y is what? All real numbers, but y cannot be 0. That's absolutely right. You guys get it? Yeah. So check this out. It really becomes a super easy section. Now, you could visually see the vertical asymptote here, or you could see the horizontal asymptote. But instead of resorting to the visuals, let's look at the equation, ladies and gentlemen, and let's ask ourselves, what is h? That'll give us our vertical asymptote, and our k value, and that'll give us our horizontal asymptote. So what is h? Remember, h is always inside parentheses with x. What's your h value? H is 0, right? There is no minus h right here, so it's technically a 0. So if you say x equals 0, the h value, that'll give you your asymptote of the vertical one. Now, how about your k value? What's your k value? It's 4. You just take it for what it is, right? Plus k. So it's 4. And that is your horizontal asymptote. So what's your vertical asymptote? It's x equals 0. So where's the vertical asymptote x equals 0? It's right here, right on the x equals 0. And what's your horizontal asymptote? It's at y equals 4, right there. Does that make sense? So it's a lot easier to get your vertical and horizontal asymptote by thinking of h and k. Think opposite on h and take k for what it is. Again, by doing your horizontal and vertical asymptotes, you'll be able to graph it super easy. So what's your vertical asymptote? It's going to be x equals a number. So if you go x equals, what's your h value? -5. So x equals -5. That's your vertical asymptote. Your horizontal asymptote is going to be what? Y equals -6. So it's as easy as going and graphing the x equals 5 line. The x equals 5 line, -5 is -1, 2, 3, 4, 5. So I draw a vertical line right through that value. And then I could go to the y equals -6. So -1, 2, 3, 4, 5, 6. And I'll draw a horizontal line right through the y equals -6. So now all we have to do is decide where our hyperbolas are going to be at. It's either going to be on this side, like this, and like this, or maybe it's on this side and this side. Does that make sense? It's either going to be here and here, or maybe here and here. Okay, now how are we going to do that? Let's go to an XY table. So going to an XY table, I need to plug in values. Now, normally I say plug in any numbers you want. However, I recommend plugging in an x value. Don't plug in an x value way over here. Plug in something that's pretty close to your vertical asymptote. Okay, so -1, 2, 3, 4. Let's plug in a -4. And let's see what happens. Okay? So if I plug in a -4 right here, -4 plus 5 is 1. Yes? What's -1 over 1? It's -1. And then -1 minus 6, what do we get? -7. So the coordinate -4, -7 will give us the answer, at least for a sketch, right? So where's the coordinate -4, -7? -4, -1, 2, 3, 4, 5, 6, 7. So I have a dot right here, guys. Because I have a dot right there, I already know that my curve is going to be like this on this side. And it's going to be opposite of that on this side. So I might as well draw a sketch like this. And on this opposite side, it's also going to be there at that same dot. So draw a sketch like this. Whoops. Sorry. I got ugly. But you know what, I'm supposed to be that way. So that's your graph. It's as easy as identifying your vertical and horizontal asymptotes and then plugging in a point to just see where your curves are in comparison, or when you're looking at those asymptotes. So let's look at number 6, for example. What is your vertical asymptote going to be? The vertical asymptote is going to be what? What is vertical asymptote? Remember, it's going to be x equals your h value. What's your h value? -4. Okay, this is your vertical asymptote. How about your horizontal asymptote? That's going to be your y equaling -2. Now, that makes total sense. If you're thinking, well, does the h go with the x equal or the y equal? Well, h is with x equals h. There's your vertical asymptote. Your k value is your y shift, so obviously that's going to be with your y equals -2. So let's graph x equals -4, 1, 2, 3, 4, -4, and draw a vertical line right through that. So there's my vertical one. Let's go for the horizontal one at y equals -2. Okay, so now all we need to determine is whether the curve is on this side or maybe on this side, right? So if it's up here, it's going to be down here. If it's over here, it's going to be over here. They're going to be opposite of each other. So let's just test one value with the xy, with an xy table. So here's my xy table. And when you pick a number for x, pick a number that's close to your vertical asymptote. So your vertical asymptote is -4, so what would be a good number to pick? 3, -3, right? Not +3. I mean, I guess that'll work also, because it'll either give you a point above or below the asymptote, and that'll tell you where it's at. Let's go with -3, okay? And let's see if it gives us a point up here or down here. That'll help us out. So if we plug in a -3 for the x value, we could do this in our head. Check it out. -3 plus 4 is 1. 1 over 1 is 1, and 1 take away 2 is -1. So when I plug in a -3, I get out a -1, and that coordinate is -1, 2, 3, -1 right here above. So right off the bat, I know that it's reflected on the other side over here, which means that my curve must be on this side and on this side. You see? It's easy. That's right. Done. Obviously, on the final exam, all you have to do is identify. You're not going to actually be graphing like this. All you got to do is identify with multiple choice.